Nivruti Rai, who is the country head of Intel India and vice president of Intel Foundry Services. She heads the Automotive Solutions group for Intel Foundry Services, providing design services and custom solutions to foundry customers. She also provides overall engineering and business unit leadership and leads operations for the India site, driving innovation, cross-group efficiencies, and execution for engineering teams. Nivruti.
Okay. Good afternoon, everyone. I know it's the end of the second day, and you just heard an amazing fireside chat between Michael and Professor Ajay Sood. So I have a very tough act to follow. What I'm going to be talking about, what is happening in this next-gen world. This next-gen world is so connected. Yesterday, the Minister Jai Shankar was talking about globalization. And honestly, globalization, nobody does it, it happens. I'm going to start with food. Did you know that potatoes and onions are not native to India, not even green chilies? And we are supposed to be like a one spicy nation, eating so much green chilies, but it's not. But we accommodated all of those foods into our daily eating and feel it's ours. So looking forward, globalization of technology is going to happen like potatoes and onions, and it will become part of our daily consumption. So my belief is technology thrives with collaboration. So my talk is going to be about building unique collaboration for innovation, because there are different facets of inventions and innovations that different people bring, and when all of it comes together, that's when magic happens. So my talk is going to look at how do we enable that by building what I called trust-based digital geographies. So you've heard about, digitalization of our biometric, our identity, e-retail, even, some diagnostics. What is interesting is, what's the next level? How can we look at, digital geographies? And I'm going to coin a word called digital neighbors. It doesn't matter in terms of how close a nation is with you. It matters how close the nation is with you in the terms of trust. And, all of us lived through this during COVID. It didn't matter whether you were working for a US company or a Belgium company or an Australian company, or they are working for an Indian company. It didn't matter where you were located. Even within India, you could be working from your home in Jammu and Kashmir and working in Bangalore. Distance didn't matter. What mattered was there a technical infrastructure available? And did you have, enough privacy and trust? That's what I'm going to talk about. So I have been talking a little bit. Can you help me? How do I move it forward? So, before I start my presentation, I'll tell you the whole goal is about, path to G20 and the presidency that India has. I honestly believe India has an opportunity to build what I call a collaboration infrastructure. So yesterday there were panels where you heard about digital transport infrastructure with 2G, 3G, 4G, now 5G, and really fast data transfer infrastructure. What I'm going to talk about, how can you leverage technology on those digital highways that can enable trust and privacy. So everybody has heard data is the new oil, data is the new electricity, you name it. And I know Michael is sitting here, he's going to laugh at me, but I coined a phrase called data is the new territory. Data is almost like land. It's very, you need to protect it, you own it. It's very sensitive, there's a lot of information, there's layers and layers and layers of data, and it's very valuable. And this is what is defining geography. In my mind, I actually see a world map which is based on digital trust, where your neighbors are, where your neighbors are who you share the data with. When you travel from one place to the other, you have something called a visa, or you have permits. When we build this trusted data corridor, and Michael, corridor doesn't mean point A to point B. It does have, bi-lanes that connect, many nations. A corridor can be between multiple nations. How can you enable trust? How can you leverage technology? So you heard about, quantum. Quantum internet could be a digital highway that we leverage. But what I am going to be talking about is how do you build a collaboration infrastructure on that digital highway such that the data is protected, the data is sensitive, so you care about it, and the data is valuable, so you can figure out a way to monetize. G20, path to G20, many of the nations are coming together. We are already building. Just yesterday in the panel, you heard Sunil Bharti Mittal talk so much about Airtel and Africa. Africa is a neighbor, is a digital neighbor, because he has, solutions that work in Africa. So already you're seeing trust-based geographies. I will talk about what is the challenge that we are facing. Data is siloed. Many countries, I was just meeting and talking to a few Israeli friends of mine. Entire country of Israel is the same number of people as Bangalore. No matter what they do, they cannot get access to the data, the richness of data, which is required to build, for example, a 5G solution. They don't. United States, 1/4 of the population of India. I'll tell you, when I go to see a doctor in India, I trust him far more because the variant of a disease that they have seen is a function of 1.3 billion people. So India is tremendously data rich, tremendously. Not only that, look at the consumption. If data was gold, if data was food, India is the leading consuming country of the world. 14 GB per month. No other nation uses that kind of data. So data is a prized commodity. We have to figure out how do we leverage that data. We are in the position as India, as a country, which has tremendous value to offer to the world. How do we build that collaboration so that our data, anybody else's data, remains protected, is private, is secure? We have lots of challenges that we need to address with just two simple things: technology and policy. I'm very excited to tell you that while quantum has been in works for 50, 60, 70 years, so is AI. But what has changed now is 1 teraflop of compute in the year 2000, by the way, 3 teraflops for a genome sequencing, 1 teraflop of ability to compute cost $50 million in 2000. Today, it's in your phone, $100. That has changed. So compute is available. You have technologies like AI, because data is available, compute is available, storage is available. And that's why we have been able to build a technology that can enable what I'm calling a data collaboration infrastructure. So I have taken the liberty to show you a very messy diagram, but literally, this is what it is. There is data transfer corridors that have been built with 2G, 3G, 4G, 5G, now 6G, perhaps even quantum internet. And just to let you know, guys, quantum internet is touted to be unhackable. Quantum internet is touted to enable data transfer at the speed of light. So if that happens, that's the corridor we will use. But how do we create a collaboration infrastructure? Let me just take a couple of, I'm going to give you an example. 5, 6 countries. How do we build a collaboration infrastructure? I already told you, Israel has so few people, like a city of Bangalore. United States is struggling because companies are walled garden in terms of data. Different companies want to keep their own data. China, no data comes out. So there's a lot of challenges. How do we leverage data? How do we create that collaboration infrastructure? There are 3 technologies that I want to talk about. But before I tell you the technologies, the segments we are focusing on, and of course not alone, not me as Intel alone. We have partners. We are focusing on health, and we are focusing on automotive and smart mobility. So what are we doing? We have partnered. I'll just give you some examples. This is not in any way a complete list. Intel India specifically, and then we have National Health System Laboratory, NHSL, in US, that's partnering with us. We have hospitals in India, Narayan Hridayalaya and Aster. We're trying to get, Biocon-like companies who are looking at drug discovery to be able to create this secure data collaboration framework, identify some of the problems that need to be solved, and build this exact structure. Like I told you, there are so many countries, each have their own AI ML algorithm looking at diagnostics, looking at patient management, drug discovery, you name it. What this will enable is data sharing, data exchange, and the ability to solve the 6 problems that have been identified. Why the 6 problems are important? Because what is the data structure going to be? How is it going to be annotated? There has to be those standards. So to enable standards and solving focused problems, we will look at what are the 6, 7 problems that we need to solve. Now, what are the technologies we are leveraging? Data has become, there is a territorial shift that we are seeing, and people are already treating data as land. So you hear about, data protection bills, data localization. Different countries are looking at, how do I territorialize my data? So technology has come to an answer. And, I have worked in Intel for a very long time. I can tell you, if you have a problem, technologists have a solution. So look at what the problem is. I do not want to move data. There is a technology called federated learning, in which you do not actually move the data at all. You actually build a distributed model, very, very tiny. Think of it as, when you have your graph, the smallest little square is a distributed model. It acts like as a point, which is the data, and it goes and fits into the model. So you don't share data. Let me tell you another technology we are using. It is called homomorphic encryption. You can work on encrypted data. Let me tell you the third technology, which this collaboration framework is leveraging, is called differential privacy. I'll tell you what differential privacy is. When you look at a data, let's say Rudra. I just know Rudra, and he has a name Rudy that goes with it. He's associated with Carnegie. I actually can get so much more information just by these 3 pieces. So there are layers and layers and layers and layers of data. Differential privacy enables you to not be able to get into those layers and keep you at the level where you're not exposing details of the data. So these 3 technologies, which is making AI much more useful. And why? Because we have very fast data lanes. We have extremely high capability compute, is enabling us to leverage these 3 technologies. And while, I am sharing this with you, this is a prototype that's already in the works. Why I want to bring it to your attention? If we need to scale it, if we need to enable more countries, today it's primarily US and India, to be honest. But there are more countries that can participate, more countries that can create value, who have a common goal of global good. How do we enable many of these benefits, facilities, health-related, accident, collision, death on traffic-related, be available to larger number of people? Similarly, this one is also very interested. I am interested in this. It's very important to me, and maybe important to many of you. I shared this number in I think day before yesterday, Rudy. India has 1% of vehicles of the world. 1%. But you'll be sad to hear India sees 11% traffic accident deaths. 17 people, or 18 now, unfortunately, will die in 1 hour in India. If technology can save 1%, I'd be very happy. The other thing is, the world is pushing for EV. Environment is important. Benefits of what EV provides with respect to oil is important. Another thing which is important is, how do we leverage technology for collision avoidance? So another statistic that I'll share with you today, in an average car, 4% of the bill of materials is semiconductors. By 2030, 20% of the bill of materials of a car is going to be semiconductors. It'll be in infotainment, it'll be for EV, it'll be for battery, it will be for centralizing compute. And by the way, I'll just tell you, speed of light is 1 nanosecond per foot. An average car is 15 feet. So 15 nanosecond is the delay I want from the front of the car to the back of the car. So where the semiconductor is being put is also important. So you'll hear in automotive industry, there's something called centralization of compute or zonal compute. Why? Because we want to be enabling a lot of benefits, including collision avoidance, in our cars where speed is important. So what we are looking at, other than health, where we want to enable clinics, hospitals, academic institutes, diagnostics labs with all of this data such that they can leverage it for a lot of research. In the automotive space, we are targeting building electric vehicles, building batteries, building smart compute. So we are looking at a similar, like in hospitals, in health, I told you that it's Intel India, it's a National Health System Laboratory. We are looking at NIH in US. We have NH and Aster in India and many others. Similarly, in automotive, we are looking at definitely India. And the government plays a huge role because there are only two things that I really, really want: technology and policy. In the automotive space, I'm looking at partnership with car manufacturers, which are called the OEMs. Then you have, the tier ones who actually build what is called the ECU, those boxes that you see. Then there are tier twos who actually build semiconductors and more designs. And many other peripheral providers, who can build the chassis, the powertrain, and all of those together. All those guys will be our partners with the goal of solving some of the things that I called out, EV, for example, smart compute for collision avoidance, etc. So those are the things that I want to solve with our partners looking at smart mobility. I don't have to tell you the story, but there is an interpretation that I want to make of this. Over the last few years, and each one of us are witness, the world ran on the shoulders of technology. So if our Prime Minister in 2015 called out digital, it's our responsibility to take digital to the level where it translates into value for the 1.3 billion people, 8 billion people of the world, not just India. And I really believe the next few decades, if we need to look at progress for our country, progress for the G20 countries, progress for humanity, the world has to run on the shoulders of technology. Whether it is quantum, whether it is trusted corridor, whether it's your digital neighbor, whether it is building 6G, 7G, all those G solutions, I think the onus is on us, because whether we like it or not, the world is already running on the shoulders of technology. Thank you very much.